So if I want to plot my reference point, I know that it's negative, so it's going to be where? To the left. You okay with that? Here's my negative 5/2. I know it's negative 2.5. I know it's between negative 2 and negative 3. That's fine. All I have to do is plot what? That reference. And then, what do I know? I have to describe numbers that are what? Greater. Numbers that are greater than this live where? To the right or to the left? What do you guys think? Numbers that are greater live to the right or to the left? All right, here we go. If you guys remember, this is where we left off yesterday. If you want to review this, this is what we called the what? This was a two-step problem. The reason we called that a two-step, right, was because you solve for x, you're getting x by itself, and it's done in how many steps? 2, in the sense that the number 2 is multiplied to x, so you got one operation, multiplication, to undo. So we have to undo the multiplication operation, and then we have that subtraction operation to undo as well. So we have a two-step situation. So what do you guys remember for the two-step problem? What do you always want to do first? You guys want to translate? So you're going to move the 5 to the other side. We translate the 5. This is very similar to, it's not exactly like, but very similar to solving equations. Remember, these are solving linear inequalities. That's an inequality symbol. So you get 2x on the left. We didn't move it. Less than or equal still to the 8. We didn't move the 8. We just moved the 5 on the left. The sign on the left is positive or negative. It's now what? Positive on the right. So we now get 2x less than or equal to, what's 8 plus 5? 13. Okay, so you got 13, and now what do you do with the 2? It's 2 times x. You divide both sides by the 2. Okay, now what happens with your 2's? What happens? They cancel out. Okay, so you have your x less than or equal to, does that fraction, can you reduce this fraction 13 halves? No. So it's 13 over what? 2. So ladies and gentlemen, this is a very important piece of information. Here, they're going to ask you, first of all, to solve the inequality. So this is the solution in some sense. You have solved this thing. Okay, so if they say to you solve, they will. You've completed that task. What you now have to do, so we completed that, I'll put a check instead. What you now have to do again is they're going to ask you that they want you to write your solution how? They want you to write the solution in what they call, they have two options, set builder notation. They may want you to graph the solution, or they may want you to write this in interval notation. Okay, so we're gonna deal with that. So let's write down the set notation. Let's see what you guys remember from yesterday. Did I give you that yesterday?
Yes.
Okay. Set notation, how does that look? You always start with your curly bracket here. And then whatever variable that you solve for, here it's x, you're reading this as set of all x, such that, do you guys remember what was the significance of solving this? That was your description of the solution. X is less than or equal to what? 13 halves. So here's your set notation. Okay, I'll emphasize that this is your set notation. Anybody have any questions on that?
So for each equation, you got to write a set notation, right?
For each inequality, not an equation.
Quality.
Inequality. If they ask you, what do?
You do it.
You do it. They may not ask you. They may say instead, solve in what? Graph. In that case, what does a graph look like? You draw the real number line. Here's a real number line. Notate the middle with 0. And then look at the reference number. What's the reference number? 13 what? Halves. Okay? Now what I do is, since that's 13 halves, is that a positive number or a negative? So I locate, 13 halves in a sense. All I really do is notate that it's positive, so it's to the right of 0. I know 13 halves is 6.5, but in order to graph this, I don't really need to have to find exactly where 6.5 is, do I? And then, what do? What does this mean? Numbers that are what? Less than or equal to what? 13 halves. So I'm going to put my circle there, and I'm going to close it because that signifies that it includes the 13 halves. Then I'm going to shade everything to the what? To the left. You say, why do I shade everything to the left? Well, because what are they asking for? Numbers that are what? Less than or equal to 13 halves. Numbers that are less than are numbers that are smaller. Smaller numbers live to the what? The left. So here's your graph, and you're going to graph this if they ask you, and then also you have interval notation. Okay, so here's the graph. We'll put it in red because it's a graph. I'm going to notate this. Here's your graph. Now what about interval notation? How does that look? Okay, we're walking again from left to right. Is that right? Are you walking on water?
Yes.
Okay, good. Where does that start? Well, it goes forever to the left. So we call that negative infinity. Because to the left is what direction? Positive or negative? That's a negative direction. And over here is what? Positive. Bless you. And then you're going to walk all the way up to what number? 13 halves. Do we include 13 halves? Okay. So you're going to put your bracket and your what? Parentheses always around the infinity or negative infinity. So what you're looking at, again, this is called what? Interval notation. Okay, so you have the set notation, you got the graph, you got the interval notation. You solve this. So what you really are doing is whatever they're asking you to do. If the instructions are to solve and graph, solve what? Graph. If it's solve and write all three notations, here's a set, here's the graph, here's your interval, then that's what you do. And remember, they want you to be proficient in all three notations. Because how we communicate in mathematics in higher courses, this is beginning algebra. But in intermediate algebra, and in college algebra, and in math analysis, and in calculus, all the higher math classes communicate with this kind of notation. Okay, so that's why you're studying the notation here. All right, anybody have any questions on this one? Yeah.
What if it was a different letter instead of X? When you wrote the set, would you write the other letter instead of X?
That's right. Let's say it's an N. Like, for example, let's look at the worksheet. Like, let's look at number 2 on the worksheet. We got negative 6n plus 7 is greater than negative 7n minus 1. Okay, is that the question number 2?
Yes.
All right. Okay, good. What do you guys notice about this? They don't want you to solve this. We're solving for the letter n. So would you notice that n is on opposite sides of your inequality, right? What do you really want? Right. When it was an equality, you wanted your letters on one side and your constants or your numbers on the other. So we're going to do here the same thing. We're going to translate this, and we're going to translate the 7. So notice this. If I'm moving the negative 7n on the right, it's now what on the left? Positive 7n. And then what do you see here? Isn't this going to be a what? minus 6n greater than, what number's on the right over here? Negative 1. What's this, plus 7? It's going to be what now? Minus 7. So what's 7n minus 6n? Is that n greater, what's negative 1 minus 7? Negative 8. Here's your solve part. Okay, so you solve this. This is the solve part. And then, what comes next? Let's write the set notation. Set of all x such that n is, it's not x now. What is it? It's n. It's the set of all n now. Such that n is greater than negative 8. So here's your set notation. All right, so you got your solution, you got your set notation. What comes next?
Graph.
Maybe they want us to graph it. We'll graph it. Okay. Now remember, what's the reference number? Because we're comparing, notice what we're comparing. We're comparing arbitrary numbers represented by the letter n with what number? Negative 8. So I have to locate negative 8. 0's in the middle. Where would negative 8 be? To the left or to the right? Okay. So I put my negative 8. Everybody okay with that? That's where negative 8 may be. I don't know exactly. I didn't do negative 1, negative 2. I don't have to. Negative 8 is to the left. I have to describe numbers that are what? Greater than that. So being greater is being larger, right?
Yes.
And larger numbers live where? To the right of this reference number. I put a circle here. I shade the numbers to the right, and then I double check. Is that strictly greater than?
Yes.
Yes. So is that an open circle? Yes. That means we do not include negative 8 in the solution. You say, why don't they include it? Because they don't have the equal sign. Okay. So here's your graph. Right? So we have the set notation here. We have the graph. So we got the set, we got the graph. What does the interval notation look like as you walk left to right? Well, we're walking left to right, is that right? Are we all the way over here when we start? Or is our feet in water?
No.
No, it only starts kind of where? Slightly after what number? Negative 8. How do we symbolize slightly after? Parentheses, good. And then comma, this goes all the way up to, when does it stop? Doesn't, goes all the way forever. So here's the interval notation. Here's your graph. Okay. So here's the three settings or the three types of answers they may want you to give. Okay, you guys okay with this? Is that easy or is that hard? That's hard. That's okay. Okay, let's do some more here.
Can we try number 5?
Yeah, we're going to try, hold on. I'm going to try these. Let's see. Well, let's look at, okay, we'll do really quick. Number 5, let's take a look. You tell me. We got x minus 1 over, is it 21?
Yes.
Okay. And that's going to be greater than what?
Negative 4 over 21.
Negative 4 over 21. Okay, good. So remember, we're solving for x now, again. What's happening to the x? You have what? Subtraction. How do you deal with that subtraction? Well, we could add to both sides. What have we been doing? Translating. Good. So if I move that fraction to the other side, you get what? X greater than negative what? 4 over 21. On the left, it's a negative 1 over 21. What happens on the right? What does it become? Plus 1 over what? 21. So you get now x is greater than, now here's what I want to say to you. You know, I want to remark to every algebra class, every student, did we cover adding fractions? Yes. So you're really responsible for knowing how to do what? Fractions.